Welcome to the Explainer. Whenever we stare at a computer screen just absolutely packed with lines of code, it's completely natural to feel, well, a little intimidated. It literally looks like a foreign language, and honestly, in a lot of ways, it is. But today, we're going to strip all that intimidation right away. We're taking the seemingly complex world of database coding and translating it into simple, logical concepts that absolutely anyone can wrap their head around.
Think about this for a second. In modern business, how exactly do you find one single, highly specific fact when it's buried inside millions or maybe even billions of rows of data? If you tried opening a standard spreadsheet with that much information, your computer would probably start sounding like a jet engine right before it completely froze up on you. You need a system built specifically for massive scale, and that's exactly what we're diving into today, SQL. It is the ultimate organizational tool for talking directly to your data.
So here's our roadmap for today. First, demystifying relational databases. Second, speaking the SQL language. Third, your very first query. Fourth, finding exactly what you need. And fifth, sorting and refining results.
All right, part 1, demystifying relational databases. Because before we can start speaking the language, we kind of need to understand what exactly we're talking to, right?
At its core, a relational database is really just a collection of data stored in tables. Each of these tables has vertical columns and horizontal rows. It's that simple. If you want a visual, just picture a massive, highly organized digital filing cabinet. Inside that cabinet, you have folders. Those are your tables. And inside those folders are neatly organized grids of information.
Let's look at some actual data to see how this works. Imagine a table called Person. You've got vertical columns for things like name, birth date, and gender. And then you have horizontal rows representing specific people, like Einstein or Dickens. Now, here is a crucial rule for relational databases. Rows do not have names, and their position isn't fixed. They are identified strictly by their contents. So we never say, go to row 2. Instead, we tell the computer, find the row with a name is Dickens. The data itself is the identifier.
Okay, now that we know what a database actually is, let's jump into part 2, speaking the SQL language.
SQL stands for Structured Query Language. It was developed way back in 1974 by researchers at IBM, and it quickly became the absolute gold standard for databases. And honestly, it's incredibly logical. Just like a standard English sentence has nouns and verbs, an SQL statement is broken down into clauses, keywords, and parameters. It's essentially just grammar.
The real secret to speaking this language fluently is understanding the difference between the rigid rules and the flexible inputs. As a best practice, keywords are written in all uppercase. These are the reserved structural words that tell SQL what action to take. You can't use them as your own table names. Parameters, on the other hand, are shown in lowercase. These are your variables, the specific columns or tables you actually want to look at. Getting this uppercase-lowercase distinction down is half the battle.
So, we've got the vocabulary down. Let's move right into part 3, your very first query. Time to actually write some code and say hello world to our database.
Building a query is a step-by-step process. You piece these clauses together to ask your question. And here's the golden rule. Every single query you ever write must contain at least a select clause, telling the database what columns you want, and a from clause telling it which table to look in. Things like where and order by come later to filter and sort, but select and from, those are your mandatory foundation.
And sometimes you just want everything at once. If you write a query that says select asterisk from a table, that little asterisk acts like a magical wildcard. It literally translates to give me all the columns. With just 2 words and a tiny symbol, you can command the database to dump absolutely every single piece of data it has in that table right in front of you.
But let's be real. You rarely want everything. If your table has 50 columns, pulling all of them is just going to be a cluttered mess. So you simply swap out that asterisk for a comma-separated list of the exact columns you want. If you type select title, job, the database hands you only those 2 columns in that exact order. You are in complete control of the output.
Grabbing whole columns is a great start, but now for part 4, finding exactly what you need. This is where the magic really happens. We're going to add some nuance to filter out the noise. Quick grammar check before we start filtering, though. You need to format your data types correctly so the database actually understands you. For plain numeric values, just type the number. No commas, no dollar signs, just the digits. But if you're searching for a word, a non-numeric string, you absolutely must wrap it in single quote marks. Same goes for dates. They get single quotes too, usually in a strict 4-digit year, 2-digit month, 2-digit day format.
All right, let's put that into practice with the where clause. This is your ultimate filter, and it always drops in right after your from clause. Imagine you only want to see countries with a massive landmass. You'd simply add where area is greater than 3 million. And bam! The database instantly filters out everything else, handing you only the massive hitters like Russia, Canada, and the US.
But what if you don't know the exact spelling of what you're looking for? Maybe you just know the name starts with a Z. That is where the like operator swoops in. It lets you search using patterns. By saying where name like Z followed by a % sign, you're using that % sign as a wildcard. It tells the system, find anything that starts with Z, no matter what comes after it. It is a total lifesaver for slightly fuzzy data.
You can even make your query super demanding by stacking your requirements. Enter the AND operator. Let's say you want countries where the gross national product is greater than or equal to 1,000 and it's less than or equal to 2,000. By sandwiching that AND operator between your two rules, both of those conditions must be perfectly true for a row to show up. It's the perfect way to drill down to a laser-focused data set.
Okay, we've extracted our perfect data set, but we're not quite done yet. Let's hit part 5, sorting and refining results, so we can format these raw answers into something polished and readable. First things first, nobody likes repetitive, cluttered data. If you're pulling a list of categories, like religions across different countries, you're going to see the same ones repeated over and over. But if you just drop the keyword distinct right after select, the database instantly cleans house. It eliminates every single duplicate row, leaving you with a pristine, unique list of categories.
And finally, we need to sort our data so it makes logical sense to whoever's reading it. We do this with the order by clause, which, pro tip here, must always be the very last clause in your query. If you add the keyword DESC, which stands for descending, SQL takes your results and sorts them from biggest to smallest, putting the absolute largest values right at the top.
And just look at the result. A beautifully structured table of countries sorted perfectly by their landmass. This is the power you now have. We took millions of potential data points, and by just using a few simple conversational clauses, select, from, where, and order by, we commanded the computer to build exactly what we wanted.
So there you have it. You've learned the vocabulary, you understand the grammar, and you've seen just how incredibly logical the whole structure is. That intimidation factor, completely gone. You've got the tools now. The only thing left to figure out is, what question are you going to ask your data today? Thanks so much for joining me for this explainer. I hope you found it as fascinating as I did. Catch you next time.